Good everyone, my name is Graphics. If you look at the front of the screen, we want to solve a problem involving differentiation of vector. And the question that is being asked in this particular problem, it says a particle moves along the curve vector arrow equals to t cubed minus 4t close bracket I plus t squared plus 4t close bracket j plus 8t squared plus minus 3t cubed close bracket k, where t is the time. Find the magnitude of the tangential component of acceleration at t equals to 2. Now, solution. Recall, we know very well that the tangential component of acceleration a sub t is equals to the acceleration dot product the unit tangent vector. You can see that closely. Now where I'm putting my arrow on top of the a because acceleration is a vector quantity. So the arrow there is showing that is a vector quantity. Now, what is a unit tangent vector? Before we can say we want to write the formula for a unit tangent vector, we must understand what a tangent is. We should know that a tangent is a line that touches a function at a single point. So when I have a circle this way and I draw a line at any of these points touching the circle, we say that particular line is tangent. Are we together? Now in this case, we're not talking about a tangential velocity. And when we talk about velocity now, remember it says a particle moves, meaning that this particle is moving about along a curve. Are you with me now? So the tangent that keeps this particle moving along this curve is said to be what? Our linear velocity. Because it's just like you riding a bicycle. The more the angular velocity, the more the linear velocity. So that tangent we're talking about now is what? Our linear velocity v. So when you say we don't want to write the unit vector of the velocity, no. So we use the unit tangent vector. And we know when you said about something, unit vector of a given vector is the vector all over the magnitude of the vector, just like I said in my previous video. So if I'm talking about the unit tangent vector, it means that what? The velocity all over the magnitude of the velocity, because we are talking about movement here along a curved path. Right? Now we move forward. Since we've gotten this, so we'll term that my equation 1. Have it in mind that if a particle is moving along a curved path, the position vector arrow, so this arrow you see here that is given our question, is our position vector. So I'll call it my displacement. Is that okay now? So we move forward. So now with this formula now, we're halfway there. We've gotten all what we want. So if I can look for my velocity and I look for my magnitude of the velocity, it means that what? And I also look for my acceleration. That means I've successfully calculated for what? My tangential component of acceleration. So let's kickstart and see. Now calculating for the velocity. My position vector arrow is equals to t cubed minus 4t close bracket I plus t squared plus 4t close bracket j plus 8t squared minus 3t cubed close bracket k. This is my position vector. How good? So when we say position, that's position vector. So when it starts moving, we'll say it is what? A displacement. So that means you know what velocity is. Velocity is the rate of change of what? Of displacement with respect to time. So I'm going to differentiate my position vector with respect to time for me to get my velocity. So it means that my velocity is what? Differential derivative of what? Of the position vector. The differentiation of what? The position vector. So when I do that, remember the general formula for differentiating. So I will just do that because of the first timers. So if I want to differentiate t cube, this is what we have, t cube. It means that I am going to bring the 3 in front of the t. Because I've brought it to front of the t, I'll subtract 1 from it. And 3 minus 1 is 2. So I'll be having what? 3t squared. That's what I'll write here. Minus, if I have 4t, I am to differentiate 4t. Remember, the t has a silent power, which is 1. So I'll bring that silent power down to multiply the 4. And I'll now subtract 1 from the silent power. And 1 minus 1 is what? Is 0. And n to the power 0 is 1. So t raised to the power 0 is what? Is 1. So 4 times 1 is 4. So I'll put my 4 here and I'll close the bracket. I'll put my I outside. Is that taken? So the next thing again, we have t squared. The same thing happens. The 2 will come in front of the t. Then I'll subtract 1 from the 2. And 2 minus 1 is 1. And t raised to the power 1 is t. Because n to the power 1 is that thing. Then 2 times that thing, which is t, is given as what? 2t. Plus, now if I have 4t, the same thing that we have there is still give me as 4. We've done that just now. So in close the bracket, I have my j. Plus, when you have 8t squared, meaning the power will come in front of the 8 now, and you subtract 1 from the power. And 2 minus 1 is 1. T raised to the power 1 is t. Then 2 times 8 is 16. Then 16 times the t, we have 16t. Minus, the same thing will happen. You want to differentiate 3t cube. The 3 will come in front of the 3 to multiply it. Then subtract 1 from the 3. So we know 3 times 3 is 9. Then the 3 up minus 1 is 2. So we'll be having 9t squared. So this is what we have, close bracket k. So what I have done here is that I have gotten the velocity by differentiating the position vector arrow that we have there, which I call my displacement. Are you with me now? So we now say that when t equals to 2, they gave us our time. So anywhere I see t, I'll put 2 in this given expression that is displayed above. So I will now start. I have 3, so I have 3t squared. So I'll represent my t with 2. So we're having 3 times 2 raised to the power 2 minus, I have 4 there. I'll close the bracket, I'll put my I. Plus 2t, I will not write the t, I will now put 2 there to represent the t. Plus 4, close the bracket, put my j. Plus 16t, I won't put the t there, I'll put 2. So I'll be having 16 into bracket 2 minus 9, open bracket, put 2 raised to the power 2 there. Then I'll close bracket, I'll have k. Now if I do the needful, from here I have my start from using both mass, start from the bracket first. So 2 squared means 2 times 2, which is 4. Then 4 times 3 is 12. 12 minus 4 is 8. Then 8 times I is 8i. Similarly, 2 times 2 is 4. 4 plus 4 is 8. 8 times j is 8j. Then go to the next one. 16 times 2 is 32 minus 2 squared is 4. 4 times 9 is 36. So 32 minus 36 is what? Minus 20. Minus what? Minus 4. So we have minus 4k. Is that taken? So that is my velocity that I have gotten by differentiating the position vector arrow. So we will now look for the magnitude, because in our formula here, we are given the magnitude of what? V. So once you get the value of V, you look for the magnitude of V also. So what's the magnitude of V here? It means that I'm going to square each of what? each of the quotient of I, j, and k, right? So we will now start. So to give me the square root of quotient of I is 8, I'll square it, plus quotient of j is 8, I'll square it also, plus quotient of k is minus 4, I'll square it. So this will give me square root of 8 square is 64, and minus 4 square is 16, because minus and minus is what? Is plus. So we're having 64 plus 16, that will give us 144. So the square root of 144 is 12. So I've gotten the magnitude of the velocity there, which is the linear velocity. So we move forward. Now, since we have successfully calculated for the magnitude of the velocity and the velocity itself, we will now calculate for that of the acceleration. And when we've done that, we are good to go. So let's move. Now, calculating for the acceleration here is by differentiating the velocity. Why? Because acceleration is what? Is the rate of change of velocity with respect to time. So that is the v over what? The t. And we know the vector of v here is giving us what? The r over the t. So d over the t multiplied by the r over the t means the square r over the t square. That is the second derivative of what? Of the displacement of the what? Of the position vector arrow. Are we good now? So we'll do that. The arrow, the t again. We'll differentiate it again. So when you do that, this is what we're having. If I should go there, the next one I have from my d arrow dt, I have here. Look at my arrow. If I differentiate 3t square, you know what will happen? The 2 will come in front of the 3 to multiply it, and I'll subtract 1 from the power. So we'll be having 6t. Now the 4 here will be 0 because it doesn't have any t. It's a constant. So it will be 0. So 6t times I will give me what? 60i. Right? So I'll go to the next one. Plus, if I differentiate 2t, I'll be having 2. Because the 2t here has the power of 1. If I bring the power to front of the 2, to multiply the 2, I'll subtract 1 from the power. And 1 minus 1 is 0. T raised to power 0 is what? Is 1, because n raised to power 0 is 1. And 1 times 2 times 1 is still 2. So times j will be what? 2j, because the 4 here is a constant, doesn't have a t, so it's automatically 0. Right? So go to the next one, which is 16t minus 90 square. So if I differentiate 16t, I'll be having 16, because the power of the t is 1. 1 will go in front of the 16. You subtract 1 from the power. 1 minus 1 is 0. 3 raised to power 0 is 1. Is t raised to power 0 is 1. And 1 times 16 is 16. Are we good? Minus 90 square. So if you differentiate the 90 square, it will be having what? 18t. That's what we have. So we have what? 16 minus 18t. Then you have your k there. So you now insert your t equals to 2. So anywhere you see t, you put 2. So I'll be having 6 times 2i plus 2j plus 16 minus 18 into bracket 2, close the bracket, we have k. So 6 times 2 is 12. So we have 12i plus 2j minus 18 times 2 is 36, and 16 minus 36 is minus 20. So we have minus 20k. So this is what we have. So we've gotten our acceleration now. Now substitute into equation 1. So I will now say that my tangential component of acceleration a sub t, giving us what? The acceleration times the velocity over the tangential, the magnitude of the velocity is dot product we have there. Now when I put my value for acceleration, I'm having 12i plus 2j minus 20k. Dot product, the value for the velocity is 8i plus 8j minus 4k. All over the magnitude of the velocity is what? Is 12. So when I expand, you know, when you have dot product, like I taught you earlier, you multiply the like terms together. So I for I, j for j, and k for k. So 12i times 8i will give us 96i square. because I times I is I square and 12 times 8 is 96. So 2j times 8j will give us what? 16j square, because 2 times 8 is 16 and j times j is j square. Then minus 20k times minus 4k is what? Plus 80k square, because minus and minus is plus. 20 times 4 is 80 and k times k is what? Is k square, all divided by 12. And when you now recall, whenever you have I square, it is equals to 1, and you have j square is equals to 1, I also have k square is equals to 1. So I square is equals to j square is equals to what? K square is equals to what? 1. So anyway, you see those relation, you put 1 there. So we'll now be left with 96 plus 16 plus 80 all over 12. And 96 plus 16 plus 80 is 192 divided by 12, and that will give us what? 16. So my tangential component of acceleration is giving us what? 16. That is my answer. Are we good? So if you have found this video helpful, please don't forget to like the video, subscribe to the channel, and also share the video to those in need. Thanks for watching.